The core idea of the expression all motion is relative lies in the concept that motion does not exist in isolation. Any object that moves does so in respect to a particular reference. In this lesson, we will probe on how different frames of reference affect the resulting velocity of objects as they move in two dimensions. For this lecture, we will talk about the concept of relative velocity, which we symbolize as a small letter v for velocity and subscript a and b. This relative velocity refers to the velocity of an object A from the frame of reference of another observer or object B. We can represent this mathematically as V sub AB is equal to V sub A plus V sub B. What can we get from this equation? This means that the resultant velocity is a summation of all vectors under consideration. Therefore, an object moving in an opposite direction has a negative sign, which we can express as V sub AB is equal to V sub A plus negative V sub B. But before we go further, let us emphasize that the arranging of subscripts in the relative velocity variable is extremely crucial in identifying the relative velocity of any given object. In our previous example, V sub AB, we shall interpret this as the first subscript represent the object possessing the velocity and is the one whose motion is being observed. I will repeat that. The first subscript represent the object possessing the velocity and is the one whose motion is being observed. On the other hand, the second subscript represents the object or observer with respect to which the difference in velocities is being calculated. Simply put, the second variable is our frame of reference. We have to agree, therefore, that the meaning of subscripted velocities may vary depending on the position from where the motion is viewed, and must thus be expressed accordingly. Let's see if you understand what I mean. I will show you two quantities with subscripts arranged differently. Very well. To understand this clearly, let us apply this in a situation. Consider, for instance, that you are seated inside a train with a velocity of 15 meters per second in the eastward direction. 15 meters per second east is the velocity of the train with respect to Earth's surface. If you will walk towards the east with a velocity of 2 meters per second, then your velocity relative to the train changes as V sub AB is equal to V sub A plus V sub B, where A is your velocity and B is the train's velocity. Let us substitute the values. V sub A is equal to 2 meter per second and V sub B is equal to 15 meter per second. We add this and your relative velocity as a train moves in the same direction as you is 17 meters per second. In most of the cases, objects under consideration change their direction and therefore are accelerating, like when airplanes encounter side winds or in motorboats swayed by the river's current. In these circumstances, the relative velocity of object is still determined by the equation V sub AB is equal to V sub A plus V sub B. But the magnitude of the resultant velocity shall be calculated using the Pythagorean Theorem. Do you still remember it? Which among the equations I will present to you is the Pythagorean Theorem? To understand clearly, let us say there is an airplane traveling south with a velocity of 113 kilometers per hour. It then experienced a side wind that has a speed of 22 kilometers per hour. Now, we mentioned that to get the resultant velocity of the airplane, we must get the vector sum of the two velocities under consideration. Since these two vectors are at right triangle to each other, we will then use the Pythagorean theorem. Our equation v sub ab squared is equal to v sub a squared plus v sub b squared. Let us substitute the values, and finally, our relative velocity is 115.2 kilometers per hour. You will notice that our first vector is in negative simply because it travels in south direction. We might be interested as well to calculate the angle and direction of our computed relative velocity, which we can get using the tangent function. Let us substitute the values and we get 0.19. We then cancel tangent by multiplying both sides of the equation by arctangent, which we will get negative 11 degrees, or 11 degrees east of south. In the next video, we will have more examples for these in order for us to fully comprehend the relative motion in 2 dimensions. That's all for this lecture. I'm Gilmar De Castro, and see you in the next video.